Now we are going to solve question number 6, which is from HMT, heat and mass transfer. And it says saturated steam at 100 degrees Celsius condenses on the outside of the tube. Cold fluid enters the tube at 20 degrees Celsius and exits at 50 degrees Celsius. The value of the log mean temperature difference, which is LMTD, is, so you have to find LMTD, which is a very simple thing to do. So what we will do is we will consider the parallel flow heat exchanger, or a condenser. Yes, right. Although you can assume anything, you can also assume a cross flow heat exchanger also, or a counter flow heat exchanger. I'm sorry, I'm repeating it once again. I'm taking it once again. Please delete this thing. Alright friends, we are going to talk about question number 6, which is from HMT, and it says that the saturated steam at 100 degrees Celsius condenses on the outside of the tube. Cold fluid enters the tube at 20 degrees Celsius and exits at 50 degrees Celsius. The value of LMTD is, so here we are considering one parallel flow heat exchanger, although you can consider a counter flow heat exchanger also, right? So LMTD is a very simple topic. You can see let us make a graph like this, and let's say this indicates the temperature of the steam, and it is at 100 degrees Celsius, right? And what happens is that because of the cold fluid, it condenses, and what happens is it exchanges heat with the cold fluid, which is actually entering at 20 degrees Celsius, and it leaves at 50 degrees Celsius. So its temperature rises and steam gets condensed, right? So theta 1 from here, what I can see is theta 1 is 100 minus 20, which is 80 degrees Celsius, and theta 2 is 50 degrees Celsius from here, 100 minus 50, that's all. And from LMTD equation, we know that LMTD is given by theta 1 minus theta 2, theta 1 minus theta 2 divided by ln theta 1 by theta 2, right? Here. So LMTD, so what is theta 1? Theta 1 is 80 minus theta 2, which is 50, natural log 80 by 50. So what you will see is that LMTD, after computing, you will get some value around 63.82 degrees Celsius. So this is how this question has to be solved, and since we were considering the parallel flow heat exchanger, so it is going to look like this, right? So I hope it's clear.